Hello and welcome to my write-up of Fusion Corp from TryHackMe. So Fusion Corp is rated hard on TryHackMe. You start off by enumerating a web application for a list of usernames. From there, we can test these usernames against Kerberos to find any ones that are valid. Once valid usernames are found, we can check for service principal names to crack hashes, or check if they have pre-authentication disabled so we can crack ASREP hashes. We find an ASREP hash and crack it. From there, we can do an authenticated LDAP enumeration to find a password in a user's object's description. From there, we can abuse the Active Directory group backup operators to backup important files such as ntds.dit, which contains hashes for Active Directory accounts, and the system and SAM hashes. So first things first, I like to start off with an nmap scan. So just nmap scv dash vvv dash t5. Just plug in the new IP here. Essentially what this is doing is running the nmap scripts and testing for and enumerating versions, and then verbose and max thread count. You can see here that RPC, SMB, RDP, Port 80, domain services, Kerberos, I think LDAP and LDAPS. It's obviously a domain controller. I'm not going to wait for these results to come out because it takes a little bit to run the nmap scripting engine. But from here we can find the domain name, which is leaked in the RDP certificate, which is just, we've got it here, cat/Etsy hosts. It is just fusion-dc fusion.corp. It's a fusion.dc is the domain name of the domain controller in the fusion.corp domain. We don't have any valid domain credentials. We're kind of limited. We can, check for any null authentication in RPC. If we can authenticate null to RPC, we can try and enumerate domain users. However, we can't null authenticate. Same with SMB. We don't have access to authenticate it without a user or password. So we're kind of hit a dead end there. From there, I went and checked the port 80. This seems to be a static template website, just like one you'd get off, WordPress, etc. Static, can't really do much. However, this kind of sticks out to me. It says like our special team, John Mikel, Andrew Arnold. This is kind of common in, a non-breach scenario Active Directory machine without valid users. There's been multiple machines I've done where you can just see like people like that are part of the staff, and you can just try and guess these to look for valid user accounts on the domain. I put all these into a user list. I did like John.Powell, J.Powell, John Powell, all in the Active Directory kind of username format, but I didn't get a hit. From here, I just fuzz directories. Feroxbuster. I like using Feroxbuster because it's pretty quick and handy for CTFs. However, I wouldn't use it on a real engagement because it's doing a lot of things, doing a lot of recursion. Don't really know exactly what it's doing behind the scenes. It's very loud, but you can turn off some of those options with tags, but it's just a CTF, so you don't really have to worry about any of that. And it gives a lot of input. Yeah, I've had Feroxbuster crash a couple of TryHackMe machines. I think they were older machines, older version of Windows. But you can see here we've found a backup directory. We'll just check this out. And it is a directory that contains the employees.ods file. So ODS is just like an Excel spreadsheet. We'll open this up here. Just open up with LibreOffice. Just don't care about that. It's just opened some of our macro documents. But you can see here, it's just a list of usernames and names. So with all these names, I found I just transform them into regular kind of domain format of usernames. So we can see here cat users, so John Mickle, Andrew Arnold, etc. I've plugged them all into different kind of formats, and from here I used Kerberoot to run these names against Kerberos to check for any valid user accounts. From here, Kerberoot, and just one username's come back, L Parker. From here, you can try and brute force passwords. I kind of do brute forcing at the as like a last ditch resort, because not really common in CTFs, because it's kind of annoying just to like sit there and brute force shit. So L Parker. We can also check for ASREP or ASREP roasting, or service principal names to try and get any hashes we can crack. In this case, we can use Impacket to crack the hash. And it's asking for the password. We don't have it. If we don't supply the password, it will just test the user for pre-authentication disabled. This command is essentially requesting all users on the domain to check if they have pre-authentication. It will use LDAP to check if any user accounts have pre-authentication disabled. However, we don't know the password, so we can't actually authenticate to LDAP. We can't get that information. If I had a valid domain account set, we could just do this command and it will look at all domain users to check if they have pre-authentication disabled. But in this case, we don't have a valid domain account, so we just have to guess whether a user actually has pre-authentication disabled. So we'll just skip the password, and you can see here it has pre-authentication disabled. From here, we can crack this hash. It's just an ASREP hash. We'll plug it into the hash file. I've already done it, and I've already cracked it with Hashcat. You can see here it comes back with a password. This password's got pretty high entropy. I'd say it's pretty complex. However, it's not complex if anyone knows the password. And it's just in the Rocky League. So we know that we have the valid domain users for L Parker. When I get domain password or domain accounts, I always put it in a word list. I create a separate word list for users, separate word list for passwords, so I can fuzz against any endpoints such as RDP, WinRM, RPC, SSH, etc. And in CTFs, you don't really have to worry about being quiet, so you can just fuzz for your heart's content. And that's what I've done. I ran netexec to test to see if we have any valid SMB logons. It comes back saying that we can log on as LPark with a found password, but I was not able to find any credential reuse with our cracked password. However, it's always good to check. From here, we can do a number of things. So what I skipped out on was any kind of basic enumeration. I didn't check RPC, I didn't check SMB, I didn't check LDAP, I didn't check any of those kind of endpoints where you can kind of leak information. So here we'll just use netexec to dump LDAP results with our user. Yep, that looks good to me. It's always important to just always enumerate. No matter how simple the enumeration is. Kind of took me a while to get to this point because I had already had a user account. I was focusing on more local privilege escalation, stuff like that, and credential reuse. But since we didn't have a valid domain account first, I wasn't able to do this enumeration. So it's important we always do enumeration on new users, etc. And this is all kind of badly cropped. Just run it with the window bigger. Essentially what I'm doing is querying LDAP with our authenticated user L Parker with our authenticated password, and then querying for object class user. We want all the object class of users results, and we don't care what we get from them. So in these second quotes, you can supply whether or not you want the distinguished name, instant type, a member of, etc. But we don't care. We want all of it. You can see here administrator accounts. It's also good. You can get a list of true domain users to try and rerun, ASREP roasting and curb roasting. Just look through these users, and here you can see on Joseph Murphy, it has in the description that the password's been set to this. So it took me a little bit longer than I'd like to admit to find this, because obviously I wasn't doing enumeration properly, because I kind of assumed I was already past that state, but I eventually, I have a checklist that I just go through always, and eventually I found this. So, let's get that one back up actually. This password here. And this gives us access to another user. But first things first, I want to run Bloodhound. I want to kind of get a good look at the domain I'm in. So for this, I'd like to use Python Bloodhound. It's just like a Python ingester that queries Bloodhound results over LDAP. And it's pretty easy to use. Autocomplete is not from root, but should be here. And this will just grab all, connecting to LDAP server, it'll just grab all information from LDAP. And let's look at this with Bloodhound. I've got a new window. Sorry, this is a little small. And we're just going to start up the Bloodhound analyzer. This may take a second. After just setting up Bloodhound, took about a couple of minutes, we now have the analyzer, and I've just imported the data from the Python ingester. First and foremost, I kind of want to look at the privileges our found users have. So we have L. Parker and J. Murphy. Let's check out L. Parker first, see if he is part of any groups or has any object privileges. You can see here, not trusted for delegation, member of remote management groups, uses domain users, and does not have any app and object control. So there's no real method of escalating privileges with the L. Parker user domain wise. Maybe there is with local privilege escalation. So I was checking that. But let's check our forgot the user we found. Members here, J. Murphy. We have J. Murphy user. And Bloodhound has tagged this as valuable, meaning that it's found a way to escalate to domain admin from the user. No constrained delegation. Member of domain users, backup operators. Okay, that's where it's getting the valuable tag from. Backup operators allows us to back up any file regardless of the ACL. So even if a file, you can only read it as administrator, any user of the backup operators group can just ignore that. So it's important to protect the backup operators as much as you would domain admins, because it's essentially the same thing. Not essentially the same thing, but an attacker may as well have been given domain admins, because you can just elevate to domain admins with the backup operator group privilege. We can read here. Let's see if it tries to give us exploitation notes. But you can see here, backup operators can override security restrictions for the sole purpose of backing up or restoring files. What we can do is dump the registry hive, so the SAM and system hive. The system hive contains the key needed to decrypt the SAM hive, and the SAM hive contains any Active Directory credentials for the local machine. Where I got tripped up is that if you dump the SAM and system hive from this domain controller, you can use inpacket secrets dump to view all the hashes from it, and these hashes are wrong. This is because the SAM and system hive are local only, meaning that they don't contain any domain credentials. The domain credential hashes are stored in the ntds.dit file, and typically on like most labs it stops there. You can just dump the system SAM files and get the administrator hash, and the administrator hash is correct. I think this is because the local administrator password is the same as the domain administrator password, so it always looks like you can get the password is correct. When doing like other TryHack machines, it may seem that it contains the domain admin password, but it's just a mere coincidence. In this example, we have to dump the ntds.dit file and the system hive to then get the domain admin hash, NTLM hash. We'll connect over WinRM. WinRM's kind of been buggy for me. I've reset my entire system. I've reinstalled the tools. It's very laggy, and it's not just on TryHackMe machines. It's offsec, hack the box. Evil WinRM is all laggy on these machines. And we'll just we'll get up the password and user. We'll get up the we'll just do, I forgot the user account already. J Murphy. Just connect over evil WinRM. From here, we're going to create a shadow disk letter. So what that means is, the C drive, etc. With the backup operator privileges, you can't just back up anything willy-nilly. There has to be certain criteria that you need to follow in order to back it up. Otherwise, it'll just say, permissions not granted. What we need to do is create another system drive that has been configured to allow backups of the C drive to be installed on it. So we'll create a system volume called X, and what we'll do is we'll make it so that we can back up any C drive files on it. Without doing this, it won't let you. So we can't just, copy the SAM hive to our our users local directory and then just get it that way. And this is not connecting because it's the wrong domain. We are now connected as the user J Murphy. So from here, what we need to do is actually create the Windows drive that we can upload, that we can back up C drive files to. And what we need to do is first create a file that we can use with the command disk shadow. This just allows us to create other drives when supplied with configuration and information, and these drives will be shadow drives, meaning that you wouldn't just be able to copy, the C drive ntds.dit into your user file. It needs to be a specific drive configured to backup files with the SE backup privilege. So we have to create a shadow volume. So that's what disk shadow is doing. And we can see here, I've already made the file, but it's called config.dsh. And what it contains is just configuration information. So set metadata. And then this location. So this location needs to be an existing directory, but the file name doesn't exist, where the file name doesn't have to exist. So this is just the location where the metadata of the volume is going to be stored. Then we can just set the context persistent no writers, and then we add the volume C alias system volume shadow. So what that means is we're referencing the C volume and calling it system volume shadow. Then we're creating it, and then we're creating the shadow volume, and then we're exposing the C volume as X. So we're creating a shadow volume of C called X, meaning that we can back up C drive files onto the shadow volume X volume. And you'll see here we've got the hashtags at the end. This is just to prove there's a space. So after each of these lines, you need to include a space. And these hashes are there just to, confirm that there's actually a space there, and you're not going to have to pull your hair out trying to figure out where the space is. And we'll just upload this. I'm going to have to just right here, upload config.sh. The reason why I'm doing this is that it's really, really hard to type on EvilWinRM. You can see here it just cuts out, and we'll just start writing stuff randomly, and then I can't delete it. I'm spamming backspace here, but I can't get rid of it. It's just really slow. After 10-15 seconds, it'll register the deletes. I've essentially just made this prompt worthless, so we'll just rerun it. So I just have to copy over, the commands. So we'll just upload config.dsh. I haven't been able to find a fix to this. I haven't looked very, very hard, but it's kind of just an issue. And from here we can run disk shadow and supply the configuration file here. And this is just running it. So you can see here it's ran disk shadow with our config file. It's exposed the X drive. Expose the shadow copy X drive. From here, we can use the Windows command robocopy to move the ntds.dit file over to our system, over to our current user J Murphy's documents directory. So what this command is doing, so robocopy is just like an advanced copying tool, and we're just using the dash backup, and then we're backing up it to the X drive Windows NTDS. So we're backupping the C drive ntds.dit file to the X drive windows.ntds, and then we're copying it over to our local directory. And you can see here it's done so. And let's just disregard the D here. After maybe 10 seconds, the command is errored out. So we can see that this file is actually located here. We can't just read the ntds.dit file. We need to have the key from the system hive in order to decrypt this. So we'll just move the system hive over to our current directory. We can do this with just the command reg save. Since the registry is constantly being changed and it's constantly in a writing state, meaning you can't like just directly copy it or directly move it or directly access it. So we have to use the special command reg save. This will just save the HKLM system hive to our current directory, and then from here we can just download it with the features provided in Evil WinRM. This may take a while. So after a quick pause, these files have been downloaded. Took about 5 minutes maybe, and we should have them on our end here. System sav and ntds.dit. From here, we'll just use the impacket secrets dump tool to locally dump the hashes. Yep. So it's gotten the system boot key from the system hive, and we can see the list of hashes now. Just rerun it so it's not line wrapped. You can see here, and we have the administrator NTLM hash. From here, we can ps exec. You can do a number of things. You can pass the hash with evil WinRM, try and crack the NTLM hash, etc. Do it WMI exec. There's a suite of things you can do with an administrator hash. Impacket ps exec, we're doing dash hashes to supply the hash, and then the administrator at Fusion DC, Fusion Corp. May take a second, we might just rerun this. You can see the hash is correct because we're allowed to access the admin file, which is only accessible by like authenticated users or the administrator. Since this is not working, we may just use WMI exec, which uses the Windows management instructions. I think that's what it's called, but it just allows for like remote management and commands to be executed kind of thing. I think it's the same format. After maybe 5 seconds, we have a shell back. And who are we? Yeah, we're the administrator at Fusion. From here, we can maybe try and get the flag. You can see here we have access to all the flags: the administrator flag, J Murphy flag, and the L Parker flag. So all 3 flags are required to complete this lab. I quite like this lab. It's kind of like a good introduction into a non-breach scenario where you don't have Active Directory credentials given. Kind of allows you to think on your feet with discovering users. You kind of have to look at the web application instead of brute forcing users or, you know, an unauthenticated SMB share. It's kind of more tactical and more thoughtful. I also like how it still relies on simple enumeration, so it forces you to focus on, you know, following those steps, following the basic enumeration, you know, sticking to a plan, and it highlights the importance of that. And also it shows like a bit of an edge case with the system and SAM hives. It shows that that actually doesn't contain the domain hashes. NTS.dit contains the domain hashes. which commonly on other machines you can just dump the system and SAM hives, and that hash would also work for the domain administrator. But in this case, it does not work. I assume from the fact that the local administrator account and the domain administrator account have different passwords, but on the machines where we can do that, they have the same password. But thank you for watching. See ya.